All right, now we were talking in the last video, this is our understanding of CMYK color separation. We were talking about how things are physically printed, right? And how do you take something that is RGB and millions of colors and turn it into just these 4 inks? It's called halftone separation, and then you have to separate them into the right angles. So I'm going to show that to you. And if you remember this digital coloring primer, it's the last step in professional digital imaging. Not for screen resolution, but for in-world printing, right? Because this is what everything is printed on professionally, 4-color offset lithography. So let me show you how we do it. I'm going to open up that new PNG I just saved that has my spot illustration and my type in it that can be used on a print-on-demand site like Redbubble without any changes, because that uses the millions of color to make kind of an expensive single print. But now if I want to make this into a professional print job, I need to change it in mode, image mode, from RGB to CMYK. And when I do that, the colors are going to shift a tiny bit, especially in the yellows. And it can be very, very subtle. But if I had really, really strong fluorescent kind of yellows and greens, you would see the difference pretty clearly. Now, what's the big difference there? So I'm going to show it to you a different way. I'm going to go back in my history. You'll see that it says RGB here. And when I change its mode to CMYK, it will say CMYK there. When I'm in RGB mode and I click on channels, which is next to layers, this is how the computer is seeing the image. Remember, light primaries use 3 color lights for each pixel. So those 3 color lights are red, green, and blue. So when I isolate the blue channel, why doesn't this look blue? It's because the computer is binary. It sees in 1s and 0s. So either the blue light is turned on or the blue light is turned off. But then because it's light, it can also see in terms of intensity. So where you see black here, that means that the blue is completely turned off. Where you see white here, that means the blue is 100% turned on. Remember that the blue is light. So whenever you're going to get white, like the whites of the eye, that blue has to be turned on pretty bright to mix with the other colors. Why do we have grayscale here? Well, because we have intensities of light. So it hasn't been color separated yet. Then we have green, and that's the blue and the green together. And you can see that that gives us yellow where they overlap. And then we have the red, and that will give us the full spectrum. What about red and blue together? Well, that gives us the magentas. What about green and red together? That gives us the really strong yellows. So all together they look like that. Now, what if we do this? CMYK. CMYK changes your channels to being about printing and ink primaries. And now it's very different. So we turn these off, and now each channel, the black, where it's black here means you have 100% black ink. Where it's gray here, it means you have a lesser percentage of black ink. And where it's white here, it means you have no black ink, like in the whites of the eye. If we add yellow to that, this is everywhere in my image where yellow is needed for printing. Sometimes really intensely, sometimes less so. Like in the smoke, the gray of the smoke. We add magenta to that, and that gives us, of course, our reds and our oranges. And then if we add cyan, that gives us our full spectrum color. Problem is, we can't print these like this because we can't print ink in grayscale. We have to separate it. So what do? Well, you pick a color for me to show this. Do we want to do cyan? Do we want to do magenta? Do we want to do yellow? The black is kind of too small on this to really matter. There's not a lot of tones. So cyan, magenta, or yellow. So here's the trick. You can't see them all. You can't see them individually without them turning gray, and we'll discuss why. But I'll show them with black. So that's the cyan. You can see kind of the tonalities of it. Here's the magenta with just the black. I think this is probably the strongest option, because you have really strong magenta in some areas and then a lot weaker. And then here's the yellow, and the yellow is just kind of strong everywhere. So if I take the black away from viewing the channels, the magenta is the only one showing, and because it's a computer and it sees in binary, now it's just either turned on or off at different percentages. Why did it turn black? That's because this is color now for color separation. The color is just the computer showing us what it is, but what a printer cares about is where is there ink and where is there not ink, right? It's binary. So now what I do is I change it. I turn it off to just that channel, and then I say image, mode, grayscale. And I have to remember that this is the magenta. Whoops, that's not good. I actually have to delete these. Channels are kind of a pain to work with, but I'll show you how it works. So once you start deleting them, there we go. Then it will isolate the channel. So that's the magenta. Now, and you'll see how it changes from CMYK now to just being the magenta channel, right? Then I go to image, mode, grayscale. Then I go to image, mode, bitmap. You can only go to bitmap through grayscale. What is bitmap? Remember, bitmap was an old name for pixel-based, for raster. But what it really is it means only black and white pixels. Right? No grays at all, only black and white. So how do I change this, all these grays, into only black and white pixels? I change it to bitmap mode. That's going to color separate it for me. So I'm going to say I want 300 pixels per inch, and I'm going to use a halftone screen, because I'm teaching you halftone theory, as opposed to some of the other ways you can do it. And then I have to set how large those dots are going to be. That's called the frequency. And then the angle. Now, because this is magenta, I don't want to use a 45-degree angle. Where's my book? I want to use an angle that doesn't overlap with 45. Here it is. And so you use one of these. This is a printer's pocket pal. I'll pass this around where the yellow is. It shows the halftone screen angles, which you do need to know for the final exam. It's also in the slides. So magenta is at 75 degrees. And because magenta is at 75 degrees, it's going to just overlap slightly with the black in a way that it optically mixes with the other inks. And then the shape I want for it, let's do round. That's classic. And then I hit OK, and this is what it does. So now it's all just black and white pixels, perfect for film work. And where the dots are all at a 75-degree angle. And where they are closer together, it's darker, which would be more magenta. And where they are further apart, it's lighter, which would be less magenta. Okay? Let's go back to the very beginning. I have programmed all of this into a meta program that you can get through our Dropbox. And when you do internal programs within Photoshop, they are called actions. So I go to actions, and under my color separation actions, I'm just going to say CMYK full run, and then I'm going to hit play. And this will automatically color separate all 4 channels for me. Very helpful for production work. So when I did that, it kind of looks like 3D, right? And I did this intentionally, not on my poster, but on the free floating spot illustration. Because the reason it offset them, it's designed to, is because it wasn't locked into one rectangle. So if I look at my channels, again, I can see them all independently, but this is still RGB. But if I look at my layers, I'll keep the white on so you can see. Now I can actually turn them off. So that's what black ink is doing. And if I zoom in, you'll see the dots. This is what yellow underneath the black is doing. This is what red underneath the yellow is doing. And you see that they're all at different angles. The yellow is at a 0 degree angle. The magenta is at 75 and the black is at 45. So here you can see the black mixed in there. And you see how they're not overlapping each other entirely. They're just hitting each other at a little bit like you see in the book that's being passed around. So when I add cyan, which is at a 15 degree angle, we need to line it up. So this is called registering. And I'm going to move cyan in. And now, this is how this illustration would print professionally if I had a really large dot size of only 20 dots per inch. So this is what you would see with a magnifying glass. That is what's called halftone color separation. The beauty of that, the reason I use this, is I can take all those layers, make a group of it, and then I can put it onto my full RGB millions of colors. So to do that, because I do this for professional work, it automatically separates out each one into their own layer. So I just have to say, don't save those. I just want the combined one. And this is how you generate film work for a printer. But I just want the combined one. And then I'm going to take this whole group of the color separations and I'm going to just drag and drop it onto my illustration. And I do this intentionally too. My color separations are at production resolution, which is 300 pixels per inch, but my digital work is at 350, so that when I enlarge it, it's going to get slightly softened at the edges, which is going to look better for screen resolution. So I have to line it up, again, registering it. There's a lot in printing about getting things lined up. And then once it's lined up, then I can decide how to have it impact my original colors. So one of my favorite techniques is to use soft light or pin light with the dots, so you get the overlap of the dots onto your millions of colors, which actually helps it print better in all conditions. Like so. Because now it's not just variations of green in the green, it's actually printing from what's called production color, the CMYK. Especially when I get it lined up. There we go. And then I can decide how strong that's going to be. All right, so that's CMYK color separation. Something to know and something to play with if you like. You would go to the Dropbox and you would download the actions folder from the Dropbox, and then you would install those actions into your version of Photoshop. Okay, so that's the final step. Something you might want to use on your final project, or if you like that vintage look, now you know a little bit more about how it works. You can always review these slides. It will show you the angles. The thing to remember is that black is always at 45, and then the others are at least 30 degrees away from 45. So 15 for cyan, 75 for magenta. Right. So my action flattens it, but it doesn't need to flatten your original. In order for the computer to turn it into like the bitmap for the different channels, it needs to flatten it. Yeah. So my action saves it as a separate file and then does it to that, so it doesn't hurt your original. All right. But you can do it to a JPEG as well, because white doesn't enter into color separation, right? Because the paper is white. So that's the exhaustive explanation of CMYK color separation, and I'm sure we'll review it again for the final exam.